All right. Today's topic, as everyone's aware of, is the new Spyder Model 5 controller. Not sure of the reasoning for calling it a Spyder Module 5. Over in Europe, they call it the IRM. I guess a room controller. I guess everything I've seen, that's what they refer to it as for a fan coil unit type control. They're branding it through webs, through the branch, Centraline, and Allerton as the ones I show on there. It's the Comfort Point Open. That's a CPO. Like when I brought the controller in on my Cyper 50 network, the BACnet network, it came in as a CPO. So I guess that's probably where this thing originated from and where they've been using it. And Merlin is Central Line, and then the Allerton NX is obviously Allerton. I really didn't find much on that one. I'm not sure if Allerton really had, they might have just gotten a release like we did, and so they haven't done much with it. But basically, it's an MSTP unitary controller. And if we look at the Spyder controllers that are in existence, plus these two new ones, this chart here is showing, you know, what we're used to working with the PUL, PUB controllers. And this Spyder 5 doesn't have a VAV version of it, so there's no VAVs listed here on the standard Spyders either. But you can see that the new Spyder 5 and the part numbers are WEB-RS-5N and RL-6N, basically S for small, L for large. You want to grab this one on the Greg's floor, the other one. And you can see the point mix there. So you're at what, 14-point controller with the small, and you're at a 18-point controller on the large one. You get one flavor, it's BACnet MSTP. You notice there's a lot more memory capabilities on this controller. The other thing that you can do with this, but not the old Spyders, is live programming and bulk engineering.
Yeah, the bulk deploy feature is pretty nice.
Because that's one of the things everybody's been complaining about since Spyders came out is, you know, why do we have to download? Yeah. No, it's not. No, it's another Spyder 5.
Oh, is it?
Yeah.
Yeah, it's a 30. Yeah, the bulk deploy feature when we did it in the second 30 class, it was pretty interesting how you can.
Well, this one's set up. You can even go in if you make a change to all the same application. It'll bulk download the changes.
Yeah.
So you're not redoing everything at one time. It's a little bit different.
This routing system in the box.
So we go through and look at the features on the controller. And what I planned on doing was going through features and then the concept of how they do their engineering mode and all that kind of stuff we're going to go through, and then I'll show their canned application in the Spyder 5. It is done with Niagara 4.4 or higher. I'm using it with the Cyper 50 as my, that's where the BACnet network goes to, and they're only 4.4, so that's why I'm running at 4.4. But from everything I've read, the Spyder 5 modules will work with 4.4 and up. Now, I haven't tried using that separately with the Jace instead of a Cyper 50. I mean, it's funny, the documentation pretty much just talks about a Cyper 50 and talking to it. I don't know why that would make a difference, but. So you can do on-the-fly engineering of your applications, and you'll see as we go through here, you can do offline and online. Live debugging, so you can actually see logic in action. I saw a couple references to simulation, but there is no simulation, at least at this point. I don't know if it's something they are talking about doing down the road. But it is live debugging, so when you're in the right mode, you can see the values live. You can do bulk engineering. You have groups of similar rooms. Remember, they refer to these as room controllers. So they always, you know, room, you'll see quite a bit. You know, whether it's fan coil, 2-pipe system, 4-pipe system. It's a unitary controller. It's programmable, so you can make it whatever you want. It does have its own function block library. It's the only library that you can work from to do the programming. and there's a mechanism to fully recover the application program and display it in the tool. So basically, if it's not like a Spyder when you didn't have the station and you had to upload it, and it's a big blob, and everything is on. There's no folders, there's no naming, unless it's the BACnet controller and it's just the I/O. You'll see the BACnet names come through. But when you bring that in, it'll bring the whole application in. And then there is an adapter coming out to be able to do Wi-Fi communications. It's basically a BACnet Wi-Fi device, but that's a future thing. Programming limitations, a little different than the Spyders. You can have up to 2,000 function blocks and up to 32 folders with no more than 100 blocks per folder. Now I think that's a low number, but they just wanted to, you can do that many folders. There's no reason to shove more than that in one folder. I read one place that talked about 150, but then when they went to another document, it said, your best bet is keep it below 100. So that's probably a good rule of thumb. But still, 2,000 function blocks is pretty damn good. I mean, what's a Spyder back? Was it 200 blocks you can put in the Spyder? That's a little bit different. In the tool itself, there are only 3 modules that you work with. And it's all as HON-IRM. The control module is actually the library of the components. If you want to think of like kit control or the Spyder tool module. So when you open up in the palette, there's all your components for doing your logic. They have another one that's an application library. So as they create canned applications, they'll be in that module. That module right now only has one. It's a fan coil. That's the one I put into the controller. And then the config one is the basic one that's required to download or have in the tool so you can actually talk to it and work with the commands that are part of the Spyder 5. And like I said, originally it was designed as a 2 or 4 pipe fan coil controller, chilled ceiling, hydronic, those type of controls. Terminal unit type controls, I guess you could say. Yeah. But you see the horsepower of it, you could do a lot more than just that. They do have a differential application download, so if you make a partial change, you don't have to go back and redo every application. You can push it down to all the controllers. Like right now with Spyders, if you have an application and you got 12 rooftops out there and you made a change, you got to make it 12 times, or you got to download it and blow away what's in each of the controllers. So that's a nice little feature. It's something I haven't played with yet, but it's definitely going to make a difference. And then that function block library, which was that control, that HON-IRM control module. It does have silk support for the TR40 series only. It doesn't have support for the TR70 series. The big one there, I decided to go bold and red, was it's not a Spyder, so you can't use the Spyder tool. It means all your applications you wrote in your Spyder library, can't use any of those. You're starting from scratch. Totally different library.
Even though they call it Spyder.
Yep. That's why I had this slide, is more to say they call it Spyder 5. That's why when I first started, I was saying, I'm not sure where that name came from, but because it's a unitary controller and it's programmable, maybe. As far as that's pretty much the only commonality. Oh, then it's MSTP, I guess, was the other. And you can see on the right there, I show the palette for the application one on the left, and then the right was it's laid out the same way. You'd expect it to be like it is with the Spyder tool, with the different folders for the different modules. But you could tell, a lot of the stuff from Europe, when you look and you see Sunblind, things like that, that's, I think, used a lot over in Europe. They have, first comment there is ideal solution when reliable, predictable control with guaranteed cycle times is required. You'll see as we go through that there's actually 2 different folders for doing your logic. And we'll go through the differences, as we move along. There is a real-time clock in the controllers that has a supercapacitor. I read in one place the small model had a smaller retention time than the large model. And I saw another document, which was just a matrix of features, and it said that both were 24 hours. So jury's still out on that. I left it with what I saw from the main document. The communication interfaces available on there. I mentioned the Silk bus, again, only the TR40s. So it's, even though it's a Spyder, there's no Silk IO modules or anything like that. You have obviously your BACnet MSTP interface. That's what's going to be talking back to your Jace. And then there's two other ports on there. One's an RJ45 connection that will be for the future BACnet Wi-Fi adapter. I think it's actually being used in Europe already. And then there's an additional 485 port on there. You'll see it on that controller, which will be used dedicated for Modbus as well. And again, that's a future enhancement. Actually does something different than none of the other controllers do. It has auto addressing for the MAC address. So it goes out and looks at what's on the bus and it creates its own. And you can actually manually change that as well. So it's not you're not stuck to having it be an automatic thing or a random thing, whichever way you want to look at it. And it is BTL listed as an advanced application controller for BACnet. Any questions so far? Okay.
Scheduling, Frank? You
Yep.
said that it's not a real-time clock. Does it have a schedule?
Oh, it would have scheduling in it, yeah.
Okay, but the scheduling wouldn't be accessible.
You know, I think in order for it to be an advanced application controller, I think it has to be able to do that too.
Okay, but without the TR70 support, you can't access the schedule?
That would be true. Yeah, to do it through a wall module.
Okay.
The next part, we look at the onboard I/O on the controller. First thing it's all color-coded. The terminal strips have specific colors, and each category there, I tried to make it color similar to show what it is. Universal inputs are blue, and they can do 0 to 10 volts, dry contact, fast binary for your counters and your pulse inputs. I could do 20K, NTC, 10K Type 2, Platinum 1000, and Nickel 1000. That Nickel 1000, TK 5000 there's a certain formula with it that's a specific type of sensor. I'm assuming that must be a popular sensor in Europe. I've never heard of it. I did look it up to make sure that it wasn't supposed to be a comma in there, like they're two different sensor types, but it's not. Then you have your analog output, 5 milliamps max. And then your relay outputs, and I put the little chart on there because it's a different inrush capability depending on which model and which relay you're working with. They do have a high inrush relay. And it's interesting, it's based on the triacs being internally or externally sourced, so somehow it's all interrelated on that controller. So the triac outputs are separate from the relay outputs, obviously. Triacs, you can go up to 600 milliamps total on the controller, up to 300 milliamps per. Now, if we start going into the actual, the bowels of the controller, the actual program components, there's some new terminology that gets used. But basically what I try to do is show on the right there in the nav tree, you can see where it says IRM program. That is the application for the controller. In this case, it came up, the controller name was CPO RS-5N, which is the small controller. That's the one I have on my board here. But within that IRM program, you can see there that there are 5 different folders folders. First one is Control Manager. That's the one that manages the application in the controller, displays the status displays whether the application is synchronized between the station and the actual controller. So there's a lot of information like that in there. And I mentioned that there's 2 different folders for your logic, and you have the choice of periodic program or event program. And typically it's going to be periodic program is what we're going to be working with. Control strategies run in a cyclic manner. So every 500 milliseconds, the program executes. So it's going to go through, and just like we're used to, it's just run over and over. Then you have your event program, and that's event-driven. It's triggered by a binary input change of state. So if it recognizes a change on the binary input, it'll trigger it to start working right away, like almost like a batch mode type thing. But it also executes every 1,000 milliseconds. I mean, I'm not sure if you're going to notice a difference between it, every second executing versus when it, a binary input changes. But they have them as 2 separate types of programming that you can do. You put your logic in each of those folders. Your physical I/O goes in a separate folder. The onboard I/O is that area. So in there is where you would have your inputs, your universal inputs, your binary outputs, all that stuff goes in there. And then in the palette, you can actually restore, which is kind of nice. It's almost like it's a template, all the I/O that's for that type of controller, and you just drop it in, and all your I/O's there. So it's not like Spyder where you've got to copy over every universal input or whatever. It allows you to work with it that way. And then you have your alarms folder, which is a folder with the notification classes, your alarm classes in there, obviously for alarming. So you can do some logic in there, or monitor your alarming from there. So they're the main categories or sections of the actual program. And as I mentioned, they keep talking about IRM. That's actually that controller. You'll notice also, and we'll go live, but it's a standard BACnet network. You'll notice there's an IRM config, and this is where there's some global commands across the controllers that you can do. You'll see they have a thing called swapping in, swapping out. I equate that to engineering mode or normal mode type of thing. So you can actually put them all, swap them all into engineering mode, or take them all out of engineering mode. You don't have to do them individually like we do in Spyder. Or you could do it individually by going to the IRM program and doing it from there. And I'll go through those things. And you get some of the concepts. We'll start talking about engineering modes. They do have an offline mode, which is basically where you're configuring and you're programming the controller offline in Niagara. You're not on site yet. You don't have a controller sitting with you. You want to be able to program everything offline. Online, you configure and program online, obviously, live in a controller. So basically on something like that, you're going to discover the controller, bring it in, and start programming it live in the controller. So you have the choice of which way you want to go. The term project is basically, and they didn't have a good definition of it, but to me, it's basically the controller database in the station. That's where it's housing the offline data and programming. So from there, you have an application in the controller, you have an application in project. So in order to download and upload, it's teaching to controller or learning from controller. That's the terminology that they're using. So you can download the application from the project to the controller using the command teaching to controller. If you want to upload it, you're learning from controller. And there's 2 different teaching modes. And it's hard to see on the right, and I'll show it live. But underneath the control manager, there's a slot called teaching mode. It's immediate or on demand. On demand means that you're programming it as you go along, but it's not actually going into the controller until you tell it teach to controller. And you'll see I have this little push button with the little yellow exclamation mark triangle. That's what all your components look like if you make a change to them and that you didn't teach them, you didn't download them to the controller. So if you have a bunch of those, you go back and say teach to controller and put it in. I'm not sure why you would. I guess there's scenarios maybe where you don't want to do it immediate. But then if you want to do it so that it's live programming, you change that teaching mode to immediate, and the changes are written immediately to the controller as you're programming. So you'll never get to the point where you're going to see those yellow triangles pop up. So with that, they call it synchronizing the application. So you'll see there's a couple slots in that control manager. It's called is synchronized. If it's yes, that means that the application of the controller matches the project application. And it tells you last time the program was changed, last time it was commissioned, so it keeps track of all that information. And you'll see the actions on that, the IRM program. That's where you have your teach to controller, learn from controller. Then there's clear controller, clear project, snapshots. I'll get into those. The swap command I alluded to. There's a bunch of new actions that obviously we never had before. So I guess you can look at, if you go back to your old Spyder tool, or not old, our current Spyder tool, you know, that's sort of like our engineering mode. You can, you know, we have the go in engineering mode or normal mode. And that's part of what, do I have it on this? It might be on the next page. Yeah, the swapping was the last concept. We'll get into that. Some of the other commands that are listed there, you have your clear controller. That's a way to clear out your controller, as it says, and basically deletes the application from the controller. And there's also the clear project, so you can delete the application out of your project as well. So I'd be, I guess, cautious using those. There's a check hardware compatibility. So basically, it's verifying your hardware is going to match the application. You know, like you go and you put the template in for the large controller, and you actually have a small controller you're working with, that kind of thing. It'll let you know if there's any problems. Then there's also the take snapshot, restore snapshot. Basically, it's the ability to back up and restore a program. So you can take a snapshot of a controller, it actually backs up that application. So if you ever have that thing fails, you go back and just say restore snapshot, and it'll restore that application to the controller. Now, you know, why they chose snapshot versus backup and restore, I'm not sure, but that was the terminology that they came up with. And then you have this concept of swapping. Swapping IRM programs. Basically, it's, as I mentioned there, it's similar to the engineering mode, normal mode of a Spyder tool. Swapping will save RAM space and reduces processor load and bus traffic. Swapping in means that you're looking at it live. So if you think about it, when you're live, it is taking up communication. Because remember, it's not, you know, everything's getting done across an MSTP network. So you have all that live programming, and you have your live looking at data. It's going to take up some horsepower in the controller, plus you're busy on the traffic. Yep, constantly. So if you swap out, basically you're freezing the controller to that, at that point. You're not going to see your program objects or anything. Like I said, it's sort of like the normal mode of a Spyder tool. So then at that point, it's running on its own and doing its thing. Obviously, when you're swapped out, you can't synchronize, so you can't do your teach or your learn because you're not looking at the application at that point. Then you have the ability to do the multiple device swap out. So you might be working with a bunch of controllers, and then when you finish for the day, you can go to that IRM config folder and just tell it to swap them all out, and then you know you're in good shape to be able to walk away. Now, another one on there I haven't tried yet, but I'm assuming based on what's written there, they didn't have it in any of the documentation that I was looking at. set controller password, so it looks like you can actually lock down your application and put a password in to be able to not get to it. At least I'm assuming that's what that's for. But when I was looking for information on it, there really wasn't. I think as they add features, they got to get caught up with the documentation. Yet there's other things where they have documentation on things that aren't in there yet, so it's a crapshoot. Then the last part of that was just a note on it that the IRM program will accept only its control components from its palette. There's no using kit controllers, no using your Spyder tool palette or your Spyder library applications or any of that stuff. There's no linking between Niagara components and the components within that controller. The linking is done through the BACnet components. So you're going to go to the points folder and you're going to discover your BACnet points and bring them in that way in your Niagara network. But so with that, I mean that's basically the overview and the concepts. Now I figure we can go in and poke the beast and see if we can break it. Any questions on what I covered? Okay. So if we could, okay. Again, this recording and also this presentation will be up on our BP Tech Center. But I also listed on the last page the where I got a lot of my information from, so you'll have access to these documents as well. As I mentioned, my setup here, and I didn't set up my my little video camera this time, but I have my Cyper 50 would be my Jace that I'm working with. So I'm tied into my Cyper 50, and if I go down and look at the BACnet network for that station, yeah, it's not the view I wanted anyway. I mean, you have your standard AX BACnet device manager view, and you can see right now I just have my Spyder 5, and I also have a standard Spyder BACnet controller. But you'll also notice, though, there's also a view called IRM BACnet device manager. There's quite a few more buttons at the bottom of the screen. Downloading firmware is done through this manager. There's no reflash tool or anything like that that you need to use separate from Niagara to upgrade firmware like we have to do with Spyders. That was a nice little added feature. They already came out with a new firmware version, and I had gone through and again trying to break it to see if the stuff really works, and without having any training or just by using the documentation, it's no big deal. It's easy to work with. You have your, obviously you have your Discover. You got to go out and discover devices, and you can bring them in. We go down and we look at the tree. You'll see that we have our controller in there, and since we're working with the Spyder 5s, this IRM config folder is in there as well. And you'll see that's where the swap in and swap out is set up to be able to do it globally. So on the controller, you have your standard points folder, like you have on any BACnet device. I can come in here and I can discover the points that are available in our controller. We drop them in if we want to see anything. I don't have anything tied to these, but these are the points you would use then to link if you had a link to something else across the BACnet network or, in Niagara. And if we go down and we go to the IRM program, this is where we have we talked about the control manager, and you can see from in here, It gives you the versions of software, how many folders, how many function blocks, number of links. Data you have to dig for in Spyder Tool. There's a couple different details depending on what you select, what view you try to go to, on what part of the nav tree of a Spyder you can get some of that information, but here it's all underneath Control Manager. It gives you what your hardware features are, so right away you can see what your I/O mix is. You go through, if you're working with it offline or on the BACnet network, this is that teaching mode, immediate or on demand. This one I didn't find till late yesterday. Couldn't figure out why everything was coming through as Celsius, and I was using the, changing the scaling to linear and then the 1.8 and 32 offset to make it work. Oh shit, there it is. So you got your imperial, so that obviously makes it easier. Communication status, if the device is online or not. If it's synchronized, I haven't made any changes since the last time I synchronized, so yes, it is. It's in sync. And then if we go down the tree, here's the application. And again, this was a canned application that I installed. You can go through and see, I mean, they're what you'd expect on a wire sheet. All the modules are all part of the, if we look down here, the HON control. Have your different function blocks, very similar to what we're used to working with the Spyder. The adaptive PID. As I say, if you go through, you'll see, it's pretty elaborate what they've got in here. And then you have the event program. There aren't any in this one. This one's just using the periodic. But if you had any event-driven batch type stuff, you could put them in here. Then we can look at our onboard I/O. Here's where we have them all set up in here, and you can see we're live. We're swapped in, not out. So we're live and able to see the live data. If I came in here and I made a change, let's say, okay, I want to change my characteristic to, I don't know, we'll say it's 0 to 10. It's telling us we're working in teach on demand. So you have to do a teach to get it to be live. I just did that just to show there's that exclamation showing that we made a change and it's not downloaded. So if we want to download it, we would come back here, action, teach to controller, and it's downloaded and it's pushed into the controller. And then the alarm folder, you can see it has notification classes, very similar to what we're used to working with the alarm service in Niagara. So if we come in here and we go to one of the, let's do it this way. If I go here and find where I have my, I want to put this back to where I had it. We're working in the logic. We wanted to, make a change or whatever. We could come in here and actually see, even if I move things around, they're not changed in the controller until you do your teach. So really, if that gets old, remember we could go back to Control Manager and say, let's do it immediate. I'm too impatient. I don't want it. 108. I want instant gratification. So now when you do that, it's actually changing as it's changing. We're working in the project, but we're looking at it in the controller, so it's doing both. We could go in here and say, let's see. I'm not going to. Well, I guess we can clear the controller because we can clear it and then do a complete. Put it back in there if we wanted to. Let's say we want to do a swap. I assume they come. Yeah, they do it in the jobs category. Backing it up, and now the RMM program shows a ghost. It is October, Halloween, you know. That was bad. So it's showing it as a ghost now, basically that it's swapped out. You'll see I don't have anything under it. Sort of like when you go to normal mode from a Spyder. Yeah. You know, you can't see the application, but you're saving on CPU usage and bandwidth and, you know, communications on the bus. We want to bring it back and we want to look at what we're doing. We come back here, we see we only have this one action. We swap it back in. I did test this yesterday to make sure it didn't blow up on me. Okay, so that's success. So now we're back to having the application there. And you'll see they have, I started poking around at the file structures. There's the backup it made when we told it to swap. They created that file. And then like the virtual XL10 files, you can actually go in there and see everything that's in that backup file. So a lot of similarities to how things are done with the Spyder tool versus the Spyder 5. Let's see, so we went through swap. So if we could take a snapshot, let's see if it shows up under. Okay, so it does it does the backup. So now we have a snapshot of that application. And we could go back in and say, okay, let's restore it. And then you get to pick which one you want to restore. See if it blew it away. Okay, and then it came back in. That application's in there. That application is also, if we go back in here, remember I said there were 3 modules that get used. The config one doesn't show up, it's not a palette, it's just something that's required. So if we go back in here, we look at the Honeywell, the HON application one, the IRM application, there's the one application in here. And that's the one we're working with. They actually do a nice job with documenting the applications. There's a lot of documentation on it. I mean, it's easy to say there's one. I hope they do a lot of documentation on the initial one. But, so I don't know what their plans are, if they actually have a lot more and they only put this one in there to start. No idea. But it's one at least to put in, to kick the tires and play with it and try to break it.
Do they have like where you can create your own library?
They don't talk about that at all. I'm not sure what would happen if, I don't know what commands we have down here, if there's a way to, does it let us write inside there? I'm really going to break things. Oh, I didn't notice that copy.
Snapshot so we can restore it.
So now if we took this and we took the program, can I copy it in there? I mean, it's there, but the question is going to be, I don't know if I can save Probably going to come back and say I can't save it once I get done. You know, when you play with the pallets and you close down your tool,
Yeah.
you can save certain things.
Yeah, I think your better bet is probably just having a folder in your machine and copying
Copying these,
those snapshots.
this repository.
Yeah.
Yeah, that's something I'll have to find out.
We're gonna have pre-built programs you could, you know, possibly put in a folder
Yeah.
for use.
I mean, the other side of it is you could always create your own, like a lot of people do anyway, you know, create your own palette and just throw stuff in there. And
Yeah, or use the templating that's built in the Niagara 4.
yeah.
Yeah.
Save it that way.
Good idea. It had the one thing I did see under the config where it was IRM config. If you right click on it, it had something with a serial number.
Yeah.
Is that for like the MAC address of the?
No, there is actually, look on there, I believe there is a serial number.
I guess you could use that as a way to identify the controller if it does the auto addressing.
Yeah, that's part of what they do have. If we go in and look, I think when we go back, we got to go back up to the BACnet network. We look at it here. If we were putting a new one in, say it's a new IRM device. Oh, it isn't in that spot.
And that was under the IRM config, under the tuning policies, I think.
Oh, under here?
Yeah.
Here, where you put the device name and then you have to look for its device ID.
Yeah, it looks like
Set it up there.
Yeah, I think it's probably just their version of service bin is that.
I'll see if I can get more information, and then I can add it to this presentation so it's, you know, at least there for reference. I know one of the documents I did see where they come out with a dialog box where you do enter it there. So I know there's a specific purpose that they cover. I just didn't go that deep when I was creating my PowerPoint. I try to do the PowerPoints for the Tech Tuesdays or something to reference when you're working with it, not just like a sales gloss over thing, so I can add more documentation. The one thing I can say on the user manual, they do have really good procedures in there and to step through. I mean, I went through all this stuff and I actually did a quick little application on my own originally, and the documentation was enough to, it was at the time, they really didn't have it posted up on Billings Form or anything, so I had to do digging and, you know, go to different places, Web Squad or wherever, to get copies of stuff. But it's pretty well written to be able to follow it to learn it. I mean, because Honeywell kind of just threw this out and said, hey, here's this new Spyder 5. You know, at the Cypher 30 training class, they had it shown there the one night when they did their little expo thing,
Yeah.
but never actually showed it live. And I still haven't seen them do any kind of webinar on it.
Yeah.
But anybody have any questions or want me to poke somewhere in here?
Hey, Frank, it's Brett.
Hey, Brett.
Hi. So, are they going to fully expand this line VAV and other controllers that you're aware of? Like,
It's a really good question, Brett. And they have not talked about that at all. There's been nothing. I mean, I expected this. I'm sorry?
I just wonder if this is like, it just seems like it's a holdover until something else. That's all. I was curious if it's worth investing the time into learning, developing another library and learning another program for just this one device. And then something else is going to come out.
Yeah, no, you're absolutely right. That, and I would have thought they would have done some type of an announcement of this new Spyder 5 series, assuming that's what this would be, with some kind of a roadmap for it. But, I mean, I've seen their different roadmap presentations, but this wasn't one of those things that was in there at the time. And I haven't seen anything in the digging I was doing online with the other brands I really didn't see anything more than what this controller is doing. I mean, it is, you know, the plant level versus doing it as a, you know, a VAV type controller. But no, I couldn't tell you.
I'd be surprised if it was a full line.
You'd be surprised if it was.
Yeah.
I mean, I guess part of it was, you know, for years, everybody complained about having the time it takes to download and do all that. So I don't know if they decided over at Central Line, or, is that right? At Central Line, that they, you know, they decided, all right, well, we're going to come up with our own and not have to do downloading. I mean, you're doing downloading, it's just being done right away as you make changes. So obviously, it's going to be quick. And obviously, it's something that must have been successful over there, and that's why they brought it here. That's all I can think of. So that's why it would be nice if these other two would, would follow that same path. But yeah, I mean, as information comes out on those things, and as I get answers on some of those, I'll make sure I get that out to everybody. But yeah, this kind of surprised all of us when they announced it, and again, nobody's ever shown any kind of presentation on what you do with it. I know, talking to Vince Kelly, he's been trying to play with it. He was working with his directly with his computer and couldn't talk to it.
Really?
He talked to Web Squad, and Paula said she's using a Cyper 50 and has no problem with it. Well, that's exactly how I'm doing it with a Cyper 50. So now I'm wondering, with the documentation talking about using it with the Cyper 50, if there's something to be said about it running with that as a Jace versus as a, you know, with your PC or whatever. I mean, that's the next thing I want to do. I was more concerned about making sure I can get to all the features of the Cyper, of the Spyder 5 for this Tech Tuesday than I was to see if I could get it working with my laptop. But that's an easy enough test to see, especially when we have a second one, the large one that we can try it with as well. But I mean, realistically, I don't see why it wouldn't work with a station hosted on a different machine, whether it's our demo license on our PC or with an 8000. I would expect it's got to work with that, but we'll put it through its tests and, you know, through its paces and test it and see what we can find, what we can break. And I mean, there's still a lot of things that I haven't touched with it, but nor have I deployed it in a real application at this point. But stinks though. You think Spyder, you think great, like the Cyper 30. Import the Spyder tool, your Spyder applications, you got a lot to work with. You're starting over from scratch with this. Different group, different, you know, different group. I don't know if the group that this, I don't know if Central Line does Spyders or not. I don't know. But, I mean, they were the things that I wanted to cover on the Spyder 5, so the floor is open for questions on it. If, you know, like I said, if you want me to show something else, review something else, speak up now.
The only thing I could think of, the reason why they came out with is a bulk deploy BACnet controller to complement the, you know, the 30.
Yeah.
And the 10s you can bulk deploy too. So.
And, yeah, two separate communication schemes, though, you would think.
Yeah.
Yeah, we were thinking about doing another on the Cyper 30. I don't know if anybody's interested in us doing another one on that, just to go through its features again and
Another Tech Tuesday.
another Tech Tuesday on it.